The word indices is a plural of the word index. An index means power. For example, if we have 8 as a number, we know that 8 is actually 2 to the power of 3. 2 is power 3, meaning 8 is 2 times 2 times 2. So here we've expressed 8, a number, in index form. Okay, suppose we have another number, let's say 16. 16 is actually 2 to the power of 4, because 16 is 2 times 2 times 2 times 2. So this is a number in index form, so in plural we say this is indices. So indices, we have many laws. We have the laws of multiplication, the laws of division. For example, if you ask me that is what is 8 times 16, so you can do this, press your calculator. But using the indices rule, the first rule of indices states that if I have a number raised to a power, let's call it m, and that same number raised to another power, let's say n, so the answer is that number, you add the power m plus n. So for example, 8 times 16 is what you want to get. But since you know that 8 is 3 raised to power 3, so that was 3 raised to power 3 times 16 is 3 raised to power 4. 3 raised to power 4. So this 2 raised to power 3 is 8, 3 raised to power 4 is 16. So the answer is 2 raised to power 3 plus 4. So in this case, 3 raised to power 3 times 3 raised to power 4 equals 2 raised to power 7. That is the final answer. And 2 raised to power 7 is 2 multiplied itself in 7 places, 5, 6, 7. So we can just come and count. Here we have 2 in 3 places, here we have 2 in 4 places. So altogether we have 2 in 7 places. There is a reason I'm explaining this way. You will understand very soon. So what we have here is the first law of indices. Now, suppose what we want to get is 16 divided by 8. What will be the answer? According to law of indices, if we have a raised to power m divided by a raised to power n, so the answer is a raised to power m minus n. That is the second law of indices. Let's see that. So suppose we are told to look for 16 divided by 8. I know we all know the answer is 2. So if we are to do this normally, we can write this as 16 divided by 8. And what's 16? We are applying 2 in 4 places, 2 raised to power 4. 16 is 2 raised to power 4, 8 is 2 raised to power 3. So 2 in 4 places divided by 2 in 3 places. So from here, this cancels this, this cancels this, this cancels this. So the answer is just 2. So according to this law, instead of doing all this step, we just subtract the power. As soon as, or as far as they have the same base, 2, 2. So in this case, we subtract. So instead of doing this, we can just write our answer as 2. Because here, this thing has raised to power 4 divided by 2 raised to power 3. Following this rule, we only subtract the power. 4 minus 3. So the answer is 3 raised to power 1. So any 3 raised to power 1 is nothing. 3 raised to power 1 is 2. Meaning 2 in 1 place. So this is second law of indices. So suppose I have this question. Let me know the answer. If I have x raised to power a divided by x raised to power b, what's the answer? Straight following this rule. They have common base. You pick the base, then subtract the power a minus b. What if I have x raised to power a times x raised to power b? According to this rule, they are multiplying and they have common base. We add the power x raised to power a plus b. So I believe you know the first and second law of indices. Now let me ask this quick question. We know that a number raised to power 1 is 2. Is that number? For example, a raised to power 1 is a. A raised to power 2 is a in 2 places. A raised to power 3 is a in 3 places. So if I ask, before 1 we have 0, what is a raised to power 0? So a raised to power 0 is what? I believe if we are used to some part of mathematics, you know the answer is 1. A raised to power 0 is 1. Question is why? So we can take that the third law of indices. Any raised to power 0 is 1. But the question is why? Now, let's do something very quick. A raised to power 0. I can write that 0 as 1 minus 1 or 2 minus 2. Let me write as 2 minus 2. 2 minus 2 is still 0. Now, if I come to this law, if we can move from the left hand side to the right hand side, we can move from the right to the left. So I can also write this one moving like this. If if we have a raised power n minus n, we say now writing a raised power n divided by a raised power n. So this is as a raised power 2 divided by a raised power 2. And I can write it as what? A raised power 2 divide a raised power 2. So this is a times a times a. an1, 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 an1. 1 times 1, 1 over next 1, next is 1. So if you raise any number to 0, the answer is always 1. Now, for example, very quick question. Let's take this. We're going to say 2 raised by x is 1. Find x. If 2 raised by x is 1, find x. So we know any number raised by 0 is 1. So this is what I can do here. This is 2 raised by x. I can write this one as 2 raised by 0. Why am I using 2 here? So that they have the same base. So meaning these numbers are the same. If they have the same base, the power has to be equal. So in this case, it implies that x equals to 0. Meaning, if I do 2 raised by what is x 0, I must get 1, which is true according to this law. So far, we have 3 laws. Let's note them out. This is the first law. This is the second law. And note, these 2 laws, we can still reverse them. For example, let's suppose I have something like this. 3 raised to power a minus x. So this is law 2. In reverse, the answer is 3 raised to power a divided by 3 raised to power x. If you have 3 raised to power a plus x, when we have plus, that's first law. That's 3 raised to power a times 3 raised to power x. And if I have 3 raised to power a minus x, I can still write this as 3 raised to power a plus minus x. Yeah, it's still the same thing. So I can still treat this one as law 2. Sorry, as law 1. How? We have plus in between. So that's 3 raised to power x times 3 raised to power what? Minus x. You take this, then you take this. So you should know how to reverse the law. You need them for some questions. Now for the third law, a raised to power 0 is 1. Anything to the power of 0 is 1. Now, the fourth law. Suppose I have a raised to power m and everything raised to power n. What will be the answer? According to the law, the answer is a raised to power m times n. And also, first, note this. A raised to power m raised to power n is same thing as what? A raised to power m or raised to power n is same thing as a raised to power n or raised to power m. Since m times n is n times m, it works that way. For example, if I have 3 raised to power 2x, this is same thing as writing 3 raised to power 2 times x. 2x means 2 times x. So we can write this as, if I have 3 raised to power 2 times x, I can write as 3 raised to power 2 or raised to power x. I can also write 3 raised to power 2 times x as 3 raised to power x or raised to power 2. They are the same. They are the same. But anytime you have something like this in mathematics, if I have 3 raised to power 2x, it's better we express it as 3 raised to power x all square for some reasons. So we always bring the number out and letter remains inside. This is useful when we get to indicator equation. We call this double power law. Let's take a question under this so that I can understand it. So we have to evaluate 8 raised to power 2 over 3. First you have to know is that 8 is set as 3 raised to power 3. Then all raised to power 2 over 3. According to this law, we multiply the 2 powers. So that's 3 raised to power 3 times 2 over 3. And from here, 3 cancels 3. So we are left with 2 raised to power 2. 2 raised to power 2 is 2 twice, that is 4. Final answer. Now, law number 1. Same base, different power. What if we have same power, different base? I have, let's say, a raised to power n times b raised to power n. Opposite to law 1. This time the base are not equal, but the power are equal. So the law says the answer is a times b or raised to power n. It's as though we are factorizing power. Same thing goes for division. If I have a raised to power n divided by b raised to power n, different bases, same power. So the law still holds, we factorize the power. Now let's move to reciprocal. So suppose we have 1 over a, or let's suppose I have a raised to power minus 1. In indices, a raised to power minus 1 is the same thing as 1 over a. If I have a raised to power minus 2, the answer is 1 over a squared. If I have a raised to power minus 3, the answer is 1 over a cubed. It is as though when you take this negative out, you do reciprocal. Remove the minus, you do 1 over. Remove the minus, you do 1 over. So we can generalize and say a raised to power minus n equals to 1 over a raised to power n. Same thing goes for fraction. Suppose I have a over b raised to power minus 1. If I take this minus away, I have to do the inverse of this. So this is become b over a all raised to power 1. Same way, if I have a over b raised to power minus 2, same thing as b over a all raised to power 2. So we have to generalize. A over b all raised to power minus n equals to b over a all raised to power n. So it means if I have something like 27 over 8 raised to power minus 2 over 3, I can take the minus away and write it as 8 over 27 all raised to power 2 over 3. So meaning whenever the power has minus, there is always a way you can get rid of the minus. Now let's move to radicals. Radicals. For example, if I have the root of a, square root of a is the same thing as a raised to power half. The cube root of a is a raised to power 1 over 3. So in general, if I have nth root of a, the answer is a raised to power 1 over n. So for square root, that's invisible to here, but most times it's not written. So that's for radical. Now let's go back to law 1. For law 1, same base, different power. For this, same power, different base. What if the base and power are different? I have a raised to power n times b raised to power n. What's the answer? There is no law that combines both. You can only combine two monomials if either they have same base, different power, law 1, or same power, different base, this is law 5. But for this case, the answer remains a raised to power n times b raised to power n. No rule. You cannot add the power, nor can you multiply the bases. Here on the board we have 10 laws. Now let's move to conditional indices. So under this, we are going to take 3 conditions. The first condition, if a raised to power n equals to b raised to power n, this time around we have what? We are equating 2 indices. If these two are equal, for this one, there is nothing we can do here, but we can make one of them the subject. We can make a the subject. To make a the subject, we can divide through by the power of a. So I can come here and write a raised to power n, b raised to power n, then divide this one over n over m. So at the end of the day, it implies that what? This will cancel each other. So m over m is 1, then here I have n over m. Or, so all there is to divide through by m. We can also divide through by n, or multiply each power by the reciprocal of this to make b the subject. So if you want b to the subject, we divide through by n. So this n will disappear and come below a. So it means from there, b will be equal to a raised to power m over n. So for the first condition, the bases are not equal, the power are not equal. Second condition, what if the bases are equal? If a raised to power m equals to b raised to power m. If they have equal power, definitely the base has to be equal. So it means a equals to b. Following this rule here, you can decide to divide each power by m. If I divide this by m, or divide this by m. So at the end, m over m is 1, 1. So that holds. If they have the same power, the bases have to be equal. Okay, this time around, what if the bases are equal and the power are not equal? What is telling us? This time around, same base, different power. So the rule says the power also have to be equal. For this base to be equal, this power must be the same thing. The question is why? Following the first rule here, I have a raised power m, a raised power n. So let's divide by m over m over m. So it means a raised power 1 equals to a raised power what? N over n. For this base to be equal, the condition is that this power also must be equal. It's simple rule. If I have 2 and I have another 2, if I raise this to 3, this to 2, they can never be equal. For them to be equal, it's either they are both 2, 2, or they are both what? Raised power 3, 3. So it means this one must be equal to 1 over m. By the time we cross multiply, m times 1 is m, so m must be equal to n, which fulfills the conditions. So in total, we can say we have 13 laws of indices. And with this, you should be able to solve any question on indices. Although some are little quadratic, so you have to understand quadratic equation. You got this one indica equation, some lead to linear, some lead to quadratic, even some can lead to cubic. So what is left now is to solve, questions, past jam questions and why questions.